So we're just going to continue going on with our exponential growth and decay, except today we're going to actually compare different time periods in the same exponential functions. So let's take a look at this first problem. It says Dylan invested $600 into a savings account in January 2000 at 1.6 annual interest rate. He made no deposits or withdrawal on the account. The interest was compounded annually. How much more money will Dylan have in his savings account on January 2010 compared to January 2004? So they're not asking us how much money he's going to have specifically on a date. They want to know how much more will he have on this date compared to this date. So what we're going to have to do is, well, we don't know how much does he have on January 2010. How much does he have in January 2004? We're going to have to plug into the formula that we already have been using, and then we can compare the two different values that we have once we find them. So we know it's a growth. So let's start with the 2010. Well, how many years passed between 2000 and 2010? It's going to be 10 years, right? So our time period we're looking at is 10 years. So let me just write January 2010. We know it's a growth because it's annually interest rate. It's compounding interest. It's going up. So he's going to have our 2000, our initial value, 1, our rate. Again, make sure you always have it as a decimal, to the 10th power, because we said 10 years between 2000 through 2010. So as we did last time, we just type this straight into the calculator. My 2000, parentheses, 1 plus 0.016, close my parentheses, to the 10th power, and I'm going to get is equal to 2,344. We're dealing with money, so I can give it 2 decimal points. I'm going to have to do the same thing now, but I have to look for January of 2004 now. So everything should be the same except for my amount of time. So how much time is there between 2000 and 2004? 4 years, right? So everything else will be the same. It's the same account, so it's going to have the same formula, except my time period is now 4. So I'm going to go back in my calculator, and I'm just going to get rid of that 10, plug in 4, and well, in 2004, it has $2,131.10. So now that I know how much did we have in 2010, we had this much in 2010, I had this much in 2004, now I can finally compare them, and they want to know how much more was there in 2010 versus 2004. All I have to do is going to be to subtract these two values. So I'm going to do 2,344.5 or 05 minus 2,131.10. I'm just going to quick type that in my calculator. 2,344.05 minus 2,131.10, and therefore he has $212.95 more in 2010 compared to 2004. Same idea, just a new problem. The value of a car purchased for $20,000 decreases at a rate of 12% per year. How much less will the car be worth after 4 years compared to 3 years? So same exact concept here. They want us to compare 4 years to 3 years. So we have to find, well, how much is it worth at 4 years? How much is it worth at 3 years? And then we'll have to subtract the values. So let's just start with my 3 years first. It's going to be my initial is 20,000. My 1, it's a decreasing, so it's a decay, minus 0.12 because my percent in a decimal, and I'm doing my 3 years first. So once again, I go back to my calculator, my 20,000 1 minus 0.12 to the third. So the value after 3 years is 13,629.44. Again, we're going to do the same exact thing, except our time value is going to be 4 years now, so everything else will stay the same. 1 minus my 0.12 to the fourth power this time. I go back to my calculator. I'm going to delete that 3, and I'm going to plug in 4. And at 4 years, it's going to be worth 11,993 and 91 cents. Sorry about that. And again, all I have to do, subtract these two values from each other. So I have that 13,629.44 minus 11,993.91, and it is 1,635 and 53 cents. So the only thing that we're doing here now is we're using that same formula 2 times to compare two different time values, and then we'll subtract the two values.